We start again from here. That was primarily a recording break because the recording file was becoming too big, so we had to take a pause. Now, with the interaction between modules and the modules themselves, how they talk to each other. Why do they talk to each other? What information do they share? So, whether these modules work in parallel or they work standalone, because the communication between modules could be synchronous, they could be asynchronous. And synchronous is where you wait for the reply before you proceed. Asynchronous is where you put your communications without waiting for a response. The response may or may not come. If it comes, you will act on it as necessary. Then we come to allocation structure. Allocation structure talks about the relationship between software elements and the relationship with of the elements with the environment. Here you do get involved with hardware, and you'll find that some of the exercises given to you in the course handout have got a lot to do with hardware. So a software architect is one person who cannot forget the hardware side of things. He has to bother about where the files will be stored, what resources will be used, what CPUs will be used, what will be run on which CPU, where will you keep the data, which data will be shared. So whether you'll be breaking up the data between multiple locations, distribution of data, all these type of decisions are taken in the allocation structure. Now let's go through it step by step. So we have said that there are three things: modules, components, and allocation. And these are three broad decision types that an architect has to take. You've got to divide into modules, see how they communicate with each other, how you allocate to resources. And within each of these, we've got various subtypes of module structures. Module structures, like the example I gave you, could be through decomposition. You take a module, decompose it into multiple modules. It could be a completely class structure, the way you have it in design. OVR will say in place of classes, you may have packages. You would have, or those of you who are developers, you know that you aggregate classes into packages based on a high coupling that classes tend to have with each other. If you find some classes, okay, I'll come back to component connector. So a number of classes which have got a high coupling with one another, they work normally together, you put them into one package. And in many programming languages, this one package is deployed in one directory of your hard disk. So a module structure can consist of packages. They could be classes also. And somebody may say that that is more with design, because class-based decisions should be taken by a designer. And here again, I tell you, the line between architects and designers tend to start dimming out. There are stages where an architect tends to work with the designer, and the designer becomes an architect. Then you have the user structure. The user structure is which module uses which module. There's a module structure called a layer structure. Layer is also a pattern. We'll come to patterns later. But when you have a layer structure, each layer acts like a virtual box. So a very famous layer is the microkernel layer on hardware. So a microkernel, for example, Linux. Linux is a shell around a machine which gives a common appearance. You can decompose into layers, but normally when we talk about decomposition, somebody mentioned a decomposition layering. You can decompose into layers, but normally when we talk about decomposing, we are talking about the generalization specialization structure. We are not talking so much about layering. When we talk about layering, we want the visibility at a certain level to different levels of developers. So a developer working on an application should not need to bother about how communication is taking place, how protocol conversion is taking place, how the system is operating with the machine. So each one of these functions could be given to a different layer. Encoding and encrypting could be a layer. Interaction with the hardware could be a separate layer. And each of these layers interacting just with the next layer. So this type of module division can be done. So in layer view, do we define the interface for each module? Oh yes, definitely you have to. In all, and when we talk about defining interfaces, that is the primary concern with the component and connector. When we come to component and connector, you have interaction between these various modules. So the nature of interaction could be of a client-server type, where you have one machine which is providing a common service. Classically, those of you who are closer to me in age, you would have seen the file servers. You used to have central file servers where lots of people would access files over there. It was just a convenient way to store data in one place so that everybody could access it. Then you ended up having the database servers. Even today, many people are using database servers where you have Oracle running on one machine in a client server configuration. A number of clients access the database over there. Then you have process. You can think of something like Unix. Unix has got various processes running, and there's a communication from one process to the other. Shared data. It's a bit like client server, but in shared data, in client server there's a protocol of communication between client and server. In a shared data, based on access rights, that data is openly available to the people who've got the rights in that particular repository. Concurrency is an asynchronous mode of operation between two components. Can we use solid principles in object-oriented concepts as one of component and connector? No, not really. Can I say that component and connector view is similar to system sequence diagram and operation contract in OAD? Well, you can say similar, but then don't treat each one of them as a class. You treat it as a subsystem. So, and the communication which we are talking about is a complete protocol, like client server. Hello, who's there? I'm so and so. Have you heard me? Yes, I've heard you. Now, please pass the message. Pass the message. This is the CRC check. Is it okay? Yes, it's okay. Now, this amount of dialogue that is done by client and server is recorded in the component and connector protocols. So concurrency is asynchronous, not synchronous. When you have two systems running concurrently at runtime, they run independent of one another. So, let's say something that I ask you to get food, and I sit on the table waiting for you to bring food. So when you are bringing food, I'm doing nothing. I'm sitting and waiting. So we are not working concurrently. But in a concurrent type of a situation, I say, please bring me the food, and you go out to collect. Yeah, case study. Next class, if you have seen the course handout, has got to do with case study. Okay, I'm giving you examples. So each one of these examples, you can take it as a case study. But we'll do a wholesome case study next time. But I'm trying to give you each one as an example, and I'm trying to be as practical as I can by giving you these examples. So even in an application, seek and peek goes into the coding level. But say you want some number crunching to be done. You've got a math coprocessor. You want some calculation to be done. You pass the request to the math coprocessor. While the math coprocessor is computing, you proceed with doing some other application. So keep doing your computation. When you get a response, this particular process is on hold. It receives the response, puts it in, and continues this process from there on. Duplex is synchronous and half duplex is asynchronous. I would not answer this in a hurry. I will try to understand it and answer it in a later session. Okay. So this is what concurrency is. So this type of communication protocol between various system modules would be called component connector. Now we come to allocation. Allocation, the most favorite allocation diagram which you find in industry is the deployment diagram. In almost any application, at the time of handing over, a deployment diagram is given to the client, which tells you where, what components of the application will be deployed. Various servers could be there, various resource tools could be there, terminals, clients, printers, spoolers, network resources, multiplexers. So deployment of your entire software solution is an allocation structure. So deployment on actual hardware or deployment on resources which consist of hardware and software. Implementation plan. How do you intend to implement? Where all will you implement, in what sequence, in which locations, which modules will get implemented in which stage? This is also an allocation structure. Work assignment. Which teams working in which organization? So today I'm sitting in Microsoft and I have allocated various components to various vendors, and I'm getting third-party testing done by the people, and all this work assignment will be based on my module structure. I'll be letting them know the component and connection structures to the concerned parties, and put together this work assignment is a form of allocation structure. Why? Who is to do that? You will be dividing it. That the architect. The question here is, why should the implementation be a moderation of the architect? The architect has got to plan out right up to the implementation level. The design, the structural design should be amenable to proper implementation. He's got to have in mind how the implementation takes place. You can have an excellent application. If the implementation was not thought of, when you come to implementation, you're just not having a proper what we sometimes call strategy for intervention. You've got an existing application, you've got to change over to the new application. The architect had to bear in mind how this is going to take place. He cannot say, here, I've got something fantastic running, now go take it. Yeah, outsourcing is a part of, is based on work assignment. See, architect will not decide now whether this project from Microsoft should go to CTS or whether it will be done in-house. But he's definitely given an adequate breakout and created individual assignable components which can now be assigned based on specialization. Sometimes it is done even in-house. You've got different specialized departments of resources, and you do a work assignment for the database components to somebody, the UIs to somebody else, and you put it up to separate teams. And an architect is supposed to decide. There's a wide variety of views that are possible. See, it's just not 3 views. And later on in today's session, we'll be talking about which views you should have. But an architect has to take a decision as to what views will give me an adequate expression of my structure. The structure he has thought of. Why he thought of the structure? Because he had quality requirements. He believes the structure is going to fulfill the quality requirements. And once he's convinced that his structure is going to fulfill the quality requirements, he has to present it through views. Now, does an architect have a knowledge of coding? Very interesting question. Theoretically, no, but most architects do have a very sound knowledge not only of coding, but lots of other aspects beyond coding also. But by the time a person becomes an architect, he may have lost touch with the actual tasks of coding. He may not be able to use a coding tool very efficiently, but he'll definitely be able to read code. He'll be able to understand what are the capabilities of code. But he may definitely be working in a new language. He should definitely know the capabilities of languages. Okay. Okay, there's somebody who wants to know how these tactics are practically used. Yes, somebody has given a very good tip here. You should be very close to technology and design of systems, but not necessarily coding. But yes, most people who are architects currently have grown up the coding way, or even if they came with a qualification that give them a high level entry, they did get involved with coding to some extent. So it's unlikely that he's not aware of coding. He may not be putting in hours and hours of coding, and in the last few years may not have done that. But that doesn't mean that he is not fairly familiar with the capability of code. Okay. Now we go into individual modules, and now I'm going to pace up a little bit because I'm not really interested in reading out the details, and most of the things that are put in the next few pages I've already mentioned while going through the situation here. So the first one, I talked about decomposition structure under module structure. I've mentioned most of the things that you will see over here. When you divide into modules, you'll have interface specifications, which I said that we have more concentration during component and connector view. Good decomposition really supports modifiability, because if the definitely loose coupling is a fundamental principle of design. So even a software architect would be very well aware of the pitfalls of high coupling, and in fact high coupling can be a major problem when you come to module level. You'd like to have a minimum interaction between modules. We'll take up more examples as we go on and see. Take for example a mail server. Absolutely no coupling. The mail server has got nothing to do with individual clients. So normally an architect, see, you gradually understanding that he's a technical person who's got a lot of general idea about systems, technology, and at the same time he's also aware about management. He knows how organizations work. Estimations and all, I don't know, some of you might do a course in software project management. Normally estimation is a project manager's job, it's not the architect's job. But architect definitely asks project managers for estimates, because without estimates you cannot decide whether a quality attribute is affordable or not. So at the fag end of this course, we'll be looking into the cost aspects, where we'll see the cost implication of decisions. So we said that the US Department of Defense defines software configuration, computer software configuration items and computer software components, which is basically a module decomposition structure. They'd like to pay for individual modules also. Then we have the user structures. I've explained to you the user structures, the concept of one module using another module. For testing modules, you use stubs normally, and to test a subcomponent, you normally use a workbench. So the actual inter-usage relationship between components is called the user structure. Then we come to the layered structure. We've talked about layer n using n-1 layer, concept of a virtual machine, abstraction. I've discussed these things earlier. Class or generalization structure. When you talk about class structure, we are basically talking about generalization. Class structure, don't take it literally in the way of design classes. We are talking about combinations of classes, could be packages. Architects do not get involved with front-end UI design. They do not get involved with the schema level. These are the specialist job. But definitely, they give an overview idea as to the expectation. Sometimes they work very closely with the analysts who, see, one thing to be remembered, the architect definitely works very closely with the architect right through the life cycle of the project. the major decisions he takes in the beginning, but he makes sure that people who get involved in other design aspects, particularly the higher level design, even when it comes to DBS schemas to some extent, but not sometimes the software architect's involvement often depends on the type of background he's come from. If he's come from a DBA background and he's grown up into an architect, naturally the people who are getting involved in the DBA design, they are likely to interact with them much closer. UI designers get involved with the architect as far as it concerns usability, because UI has a big bearing on usability. But he will not be bothered about the details of UI, but he'll definitely be bothered as to whether the UI has got a good usability or not, and the ways of testing usability. Nowadays, you normally do workshops to establish usability of a software. Okay. Then we come to component and connector. There's lots of input I'm getting, and I'll definitely collate it and use it in some way. But what is definitely emerging is that an architect's job is serious stuff, and you've got to indulge a little beyond the requirement of examination. You know, remember one thing, in a course like this, scoring the examination is very easy, because most of the stuff which an architect has got to know, we cannot even test in a test situation. So basically, you're doing the basic functional process that, fine, this person can be given a degree, we can certify that he knows a little bit about the subject called software architecture, and he could even be given an A grade. But the reality is, even this course is not enough. You've got to do a lot of reading. So if you really want to become an architect, you've got to make yourself aware of a lot of cases. You've got to read magazines. You've got to be aware of the latest developments in technology. Okay, so component and component and connector, you get a chance to express the performance and availability. So you want to express the performance and availability. We will get into this. There are lots of requests or suggestions coming in here. In fact, it's moving at a very fast pace, this chat box, and it becomes difficult to track it when you are here. And normally I don't divert from the course based on what, but wherever it's relevant, I try to bring it in. So in a component and connector, all the components have got to be delineated, and what type of connections, what type of communication protocol they have between them has got to be shared data. When you may be sharing data, file services, or could be video services, could be data services. Any type of sharing of data has to be brought out. With the issues relating to performance, data integrity could be addressed over here. Client server, we've discussed what a client server is. If there's a component and connection relationship of a client server nature, you have a server which is providing a service to a number of clients. In an allocation structure, allocation to people who are working, allocation to networks, allocation to hardware, all these are shown. Now, if a component connector has to work, it has to use certain hardware entities. So that needs to be expressed in the deployment structure. Implementation, it involves integration, configuration, environment management. These issues are addressed by the architect so that a proper deployment of the system and implementation, intervention into an existing environment can be taken care of. So understanding of management processes also becomes important to an architect. Work assignment is basically assigning the work to various departments, outsourcing. Within the company, multiple locations could be there, multiple specializations could be there, multiple teams could be there. How the project can be divided to suitably deploy to various teams is taken into account, and that is why an architect cannot work in isolation from his environment. He has to understand very well the development organizations which are available to him. Work assignment is a PM's job, but the PM may not be an architect, in which case he has to sit very closely with the architect to be able to break up the job so that the project manager can now give it to various teams. Breaking up the project into teamable work is an architect's job. An architect and a project manager have to work very closely together. It's another matter in a smaller organization, the project manager may be the architect, or the architect may start managing the project. But when the moment you scale up to a certain level, the architect may be interacting maybe not with one project manager, there may be multiple project managers. And he understands the concern because he becomes a stakeholder as far as the architect is concerned. Project manager is a stakeholder. And all the resources, the technical resources that are available to the project manager are also to some. So a small tabulation has been done, with structure, what type of relationship it shows, and what it is useful for. My suggestion could be you could consider memorizing this table from a purely examination point of view. From a practical use point of view, these tables are always available to you, books are available to you. But at this stage in the course, there are certain things, if you commit to memory, they help you in understanding things later. So here is the table. Here we talk about the component interaction structures, and these are the allocation structures. So you could go through this. Then, after showing you the next page, we are going to take a 10 minutes break, where you can go and have a cup of coffee. But just before the break, I will show you what Krachen's 4-view architecture is often called 4+1 view. But let's talk about 4 now, we'll add the 1 later. Krachen, he belongs to the IBM relation group, and he says that basically for any architecture, you require 4 views. One should be logical, one should talk about process, one should talk about development, one should talk about the physical infrastructure. So logical should look up the key abstractions, logically how the whole application is going to work, how it's going to get broken up into modules. That should be the logical structure. Process is concurrencies, distribution of functionality, component and connector type of view should be there. Development is how to organize the software modules, what will be the libraries, what will be the subsystems, who will be developing, how do I allocate it to various people in the development team. And physical view has got to do with applying it to physical resources, which communication channels to use, what processes will be there, which servers will be used. So there's a 4 important views in the minds of these people at IBM, and with that I'm finishing module 1, and I close this session, and we get back again